Welcome back, guys. We are continuing on with our algebraic reasoning unit. So remember, we just got through covering exponents, prime factorization, and the orders of operation. Well, now we're moving into the next section. We're going to be starting with our equations. Now you'll be like, oh, miss, equations, I'm not going to make it. Don't worry, I have notes and I have vocabulary and I have some examples for you, and then you're going to do some practice on your own. So let's go ahead and start with our vocabulary. Let me share my screen. Share. All right. Let's see what I got. Notes on equations. You like my Bitmoji, guys? I got a cute little Bitmoji down there. All right. First thing, let's look at this. 4 plus x equals 10. X equals 10 minus 4. X equals 6. Hold on. When we learned Roman numerals, x was a 10. Now it's 6? What's going on around here? So remember a while back when we were talking about multiplication, I said, guys, as sixth graders, we're no longer going to use x as multiplication. We're either going to use a dot or parentheses. Well, now you're going to find out why. X no longer just represents multiplication. It represents a missing number. X is what's going to be called a variable, and we'll talk more about that in just a second. So that's why we no longer use x for multiplication. It's representing a missing number. Let's look at the next slide. Our first vocabulary word is an equation. An equation is a mathematical sentence showing two expressions are equal. An equation contains an equal sign. So they want you to find an answer when you're looking at an equation. So look at my little picture here. Here's x, the variable, adding 5, and it equals 10. So again, what makes an equation is an equal sign, okay? All right. A coefficient is the numerical factor of a term that contains a variable. What's a variable? A variable is a symbol, usually a letter, used to represent a number. So look at my example. This is called a coefficient because it's attached to a letter, which is a variable. Now this variable can be x, y, z, it can be a, b, c, it can be any letter in the alphabet. A variable represents a missing number that we have to solve for. So when you see a number and a letter together, it's called a coefficient. When it's just a letter by itself, it's called a variable, okay? A constant is a term without a variable. So a constant is just a regular number, just a regular number, constant, okay? All right, an expression is a mathematical sentence that does not have an equal sign. So notice, here's an equal sign. I solved for something. An expression has no equal sign. They don't want you to solve. Usually they want you to combine things that are the same to make it a simpler problem. So notice 3x plus 4y minus 5. They didn't ask you to solve anything. Or this example, negative x plus 9. Nothing to be solved. Okay, so that's the difference between an expression and an equation, is that equal sign. Okay, so that was our vocabulary. Now we're going to go into our notes and some examples. So let me share my screen for that. Share. Share. There we go. All right, so let's look at our notes. So solving one-step equations using addition or subtraction. So the first thing we're going to talk about is the addition property of equality. You're like, oh my God, miss, oh my God, what are you talking about? Don't worry, it's not as bad as it sounds. It's just a big fancy word for saying that you're going to add to both sides of the problem to solve. So it says when you solve an equation by adding the same number to each side of the equation, you are using the addition property of equality. The reason why it's equality is because whatever you do to one side of the equation, you have to do to the other side. This is to keep it balanced or equal. Okay, so equality. So let's look over here. It says x minus 2 equals 3. Well, we're trying to solve for x, the variable, what that missing number is. So in order to do that, I have to get x by itself by getting rid of the negative 2. So the opposite of a negative 2 is a positive 2. So because I added 2 on this side, I must also add 2 on the other side to make sure it balances out. When I do that, I get x equals 5. So we're going to talk about how we got that answer. Let's look at these. Remember our integer rules, ladies and gentlemen, from earlier in the year? When we're adding and subtracting integers, a negative and a negative stays a negative. A positive and a positive stays a positive. If they have different signs, you keep the sign of the bigger number, okay? So let's go ahead and look at it. All right, our first example says x plus 5 equals 8. Now you may look at this and say, oh, miss, I can do that in my head. Good. But as the numbers get bigger and we start throwing fractions and decimals in there, you're gonna need to know how to solve for these variables. So if you can do mental math to solve that, that's excellent. All right, so here's my variable, x. X is the missing number, and I need to figure out what it is. Because I have a positive 5, I need to get rid of it by subtracting 5. So I'm going to subtract 5 over here. And because I'm subtracting 5 here, I need to also subtract 5 on the other side. Remember, I'm trying to keep it balanced or equal, okay? A positive 5 and a negative 5 cancel each other out, and I'm left with just the x, okay? I'm going to bring down my equal sign. And then on this side of the equation, I have x minus 5. Not x, 8 minus 5. 8 minus 5 will give me 3. Now, don't just slap that in there as an answer. You can check to make sure. So now I'm going to rewrite the problem now that I think I figured out x. So I'm going to replace the x with a 3 because that's what I think it is, plus 5. And I'm going to add that. 3 plus 5 does indeed equal 8, which is what the problem said. So I know that my answer is correct. My missing variable x is 3, okay? Now let's do it with a negative number. I have x plus 5 equals negative 8. Again, I want to figure out the missing variable x by doing the opposite. I need to get rid of the positive 5. The opposite of a positive 5 is a negative 5. And what I do to one side of the equation, I must do to the other. A positive 5 and a negative 5 cancel each other out, and we're left with x, which is what I want. Over here on this side of the equation, I have a negative 8 and a negative 5. Remember, when they have the same symbol, I keep that symbol. So I'm going to keep the negative, and I'm going to add the numbers together. 8 plus 5, so 8, 9, 10, 11, 12, 13. Okay, so I think that my x is equal to negative 13. Well, I can check that. I'm going to rewrite my problem. Negative 13 plus 5 equals. All right, because they have different signs, I'm going to subtract them and keep the sign of the bigger number. I'm going to do 13 minus 5. Got to borrow. 5, 6, 7, 8, 9, 10, 11, 12, 13. I get an 8. Okay, but remember, I have to determine which number is bigger. If I cover up the symbols and just look at the numbers, I have a 13 and a 5. The bigger number is a 13. So I'm going to keep the sign that's in front of it, which is a negative. So negative 8. And that matches what I had up here in the problem. So therefore, my answer of x equals negative 13 is correct. Okay. All right, let's do another situation. Let's look at this one, the subtraction property of equality. You can use the inverse operation to solve equations. Inverse operations undo each other. For example, to solve an addition equation, you use subtraction. When you solve an equation by subtracting the same number from each side of the equation, you're using the subtraction property of equation. So just like we did with the addition property, we have to use the subtraction property the same way to keep it balanced. Okay, so let's look at our examples. Okay, we have x, which is our variable, minus 45, and it's supposed to be equal to 90. Okay, so I want to get x by itself, but in order to get it by itself, I have to get rid of our negative 45. Opposite of a negative 45 is a positive 45. Remember, what I do to one side of the equation, I must do to the other. A negative 45 and a positive 45 cancel each other out, and I'm left with x, which is what I want. Over here, I'm going to add 90 plus 45. 0 and 5 is 5. 9 plus 4, 9, 10, 11, 12, 13. So I think x is equal to 135. Remember, I can check this. So I'm going to replace x with 135. And it says minus 45. Okay. I don't know about you guys, but I can't subtract this way. So I need to line it up. 135 minus 45. Okay, 5 from 5 is 0. I need to borrow 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 9. Okay, so 135 minus 45 is equal to 90, which is what my problem stated. So therefore, my solution is correct. X is equal to 135. All right, one more, ladies and gentlemen. Let's do it with a negative number. I have x minus 90 equals negative 45. Again, I'm trying to get the variable x by itself by doing the opposite operation. Because I have negative 45, negative 90, I'm going to do a positive 90 on both sides. Got to keep it equal. A negative 90 and a positive 90 cancel each other out, and we're left with x. Okay. Now over here, we have a negative 45 and a positive 45. Negative 45, and a positive 90. Sorry, guys, I keep saying 45. All right. They have different signs. Because they have different signs, I need to subtract them. Gotta borrow 10 from 5, and then 8 minus 4 is 45. Okay. I'm going to ignore the signs in front of them and just look at the numbers. 90 is bigger, so that means I'm going to keep the sign in front of it, which is a positive. So that means this 45 is positive. Okay. Now you might be like, oh, miss. What happened? It's supposed to be a negative 45. You're correct. Remember, we have to check our answer. Okay. So we're going to come over here and put 45 minus 90 and see what it equals. Okay. I have a positive 45 and a negative 90. They have different signs, so I'm supposed to subtract them. I know that 90 minus 45 is 45, but if I ignore the symbol, the 90 is bigger. In front of the 90 is a negative. So negative 45, which is what it states up here. So positive 45 is our correct answer for X. Okay, ladies and gentlemen, that is our introduction to equations using addition and subtraction. Remember, whatever you do to one side of the equation, you must do to the other side to keep it equal. Okay, you're doing the opposite operation in order to solve for the missing variable. You're going to go do a couple problems on your own, and I'll see you tomorrow.